Projectile Motion by Allie Lesser, Dylan Gregory, and Jordan Myers.
Hi, I'm Dylan Gregory, and our project is Projectile Motion. Jordan! Galileo was the first person to discover projectile motion, and he did this by analyzing the vertical and horizontal components separately. People before Galileo thought that whenever an object was shot into the air, it would go in a straight line and then it would eventually just plop to the ground. But Galileo proved them wrong, and when in fact a ball or object is thrown into the air, it goes in a parabola, like this.
Hi, I'm Allie Lesser, and I'm in Dylan Gregory and Jordan Myers' physics group. And for our project, we did projectile motion. Originally, what we were going to do for our project was take a potato launcher and shoot potatoes, but we couldn't figure out how to work that. So next, we decided we would try it with marshmallows, but we couldn't find a marshmallow gun. So we are now to this Nerf gun, and what we did with this Nerf gun is we took it at these different angles and shot it. And the angles are 0 degrees, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, and 90 degrees. In each one of these degrees, we measured the distance that it traveled.
Hi, my name's Jordan Myers, and I'm going to talk about the variables and controls in our experiment. So our independent variable is the angle that we used, and we used a protractor to measure the angles. And our dependent variable is the distance that the Nerf traveled. And our control is the Nerf gun.
To keep our angles stable, we attached our poster board to the car, and we're going to shoot it down the driveway. We're doing 0 degrees. Ready? Go. Okay.
What we're currently doing is measuring the distance from where it was shot to where it landed.
Come here.
Oh, it's at 103.5.
So ours was 403.5.
This is going to be 50 degrees.
It's right here.
Make it straight line. Oh my goodness.
Here.
Well,
Here, no, I know what to do.
helpful.
Do this.
That's good. Straight line. Okay.
Damn.
I couldn't. Where's the thing? Okay.
How much is it? It's 357.5.
Okay. This is gonna be 80 degrees. And on the front. Nope.
It's right here.
Okay. We're gonna bring it out. Nice job, Ellie.
Thinking on my feet.
Ready? And it is, Allie?
116.
Point.
It's just like right on 116. So this is our data, and we converted inches to meters. At 0 degrees, it was 10.25 meters. At 10 degrees, it was 10.98 meters. At 20 degrees, it was 13.62 meters. At 30 degrees, it was 12.18 meters. At 40 degrees, it was 11.54 meters. At 50 degrees, it was 9.08 meters. At 60 degrees, it was 7.91 meters. At 70 degrees, it was 3.70 meters. At 80 degrees, it was 2.95 meters. And at 90 degrees, it was 0.93 meters.
After our experiment, we plotted our data on this graph. As you can see, as the degrees increases, the distance the ball travels, or the Nerf travels, is at a decrease. Before the 45-degree mark, the distance of the Nerf is at an increase, but after the 45-degree mark, it starts to decrease. The shape of our graph is like a parabola as it goes upward and curves down.
Hi! For our first diagrams, we drew two separate ones. One for while the Nerf was in the air, and one for when it was in the ground. The forces being applied while the Nerf is in the air was the long-range force of gravity pulling down on the Nerf. The forces being applied while the Nerf is on the ground is the long-range force of gravity pulling down on the Nerf while the ground is pushing up.
So for our mathematical model, we linearized our data by doing the square of y directly proportional to x. So whenever we linearized our data from 0 to 45 degrees, because it is a different equation if we do it the whole entire graph or data or whatever. So that ends up being meters squared is equal to 0.84 meters squared over distance plus 121.7 meters. And the slope of our mathematical model is the rate of change in our parabola.
My job during our experiment was to speak, measure the distance, draw the graph, shoot the Nerf, and film.
My job in our project was to shoot the gun that held the Nerfs,
That helped.
to measure the distance the Nerfs went, to speak, and to draw the force diagrams, and to film.
I filmed and I made video, partially, mostly. And I did the mathematical model, and I shot the Nerfs, and I was the model of the whole entire project, and I did the mathematical calculations as well. Yeah, I think that's it.
That's close.
Drinking is very bad. Yo, I got a fake ID though.
Jordan, I mean, we're recording.
Yeah.
To measure our angles, we used a protractor. And what we're gonna do with this Nerf gun is shoot it.
Okay.
Why is this shot?
Like she a groupie and I ain't even no tour. Maybe cause she